All right, guys. Today's topic: logarithmic functions. Logarithmic functions. There we go. All right, logarithmic functions. Now, this is a topic that is kind of new to you, although some of you may already know what is a logarithm. Some of you may, right? If you don't worry. I'm going to explain all of that today. Don't worry about it. All right. Now, this topic, as I said at the beginning, this topic is directly connected with the previous topic. So this is why I wanted to show it to you today. And let's begin with the definition. What are logarithmic men? What are logarithmic functions? There we go. Logarithmic. All right. A logarithmic function is the inverse of an exponential function, right? So what is the inverse of addition? Well, we know the inverse is subtraction, right? The inverse of plus is a minus. The inverse of addition is subtraction. What is the inverse of, I don't know, division? Well, the inverse of division is multiplication, right? Beautiful. Well, what is the inverse of an exponential function? The inverse is a logarithmic function. All right. And these, the inverse, we use them to isolate variables, right? Remember, when we have I don't know, a number adding to a variable, we pass it to the other side to subtract, right? So we change with the inverse operation. And this is exactly how we are going to use logarithmic functions. We can now isolate exponentials by using logarithmics. All right. This is the real definition. Go ahead and write it down, please. This definition says the logarithmic function to the base a. This is how you read it, all right? This is how you read it. The logarithmic function to the base a, where a is bigger than 0 or more than 0, and a is different than 1, right? So we cannot have a and the value a cannot be 1. It has to be bigger than 0, right? Is denotated like this. Let me just take recortes. Recortes right here. My tool. Here. All right, this is what I want you to focus on, guys. This is the value of a that has to be bigger than 0, right? And also cannot be 1. Right? Cannot be 1. Right? That is the value that cannot be 1. So you can have something like this. Y equals logarithm. By the way, this is how you read it, right? Look, read as y is the logarithm to the base a of x. So this is how you read it. Y is the logarithm to the base 3 of x, for example. That's how you read it, all right? Remember, mathematics is also a language. So you need to know how to write it, but also how to read it, right? So this is y is the logarithm to the base to the base 3 of x. Again, to the base 3 in this example, right? In this one, it will be to the base a. And depending on the number, well, that will change the base, right? Let me just erase all of this, whatever. All right, now, this is the connection we have with the exponentials. Look, whenever we have y equals logarithm to the base a of x, we can also change it by x equals a to the y. The base a to the y. So look at this. At the beginning, y was the answer to our logarithm. Let me do a couple of lines in this. Maybe I can show you better. Take a look at this. What happened? There. Take a look at this. This is the main equation, and this is the one I am transforming it to. Right? Now, take a look at this. Y, which was the answer, once I transform it into an exponential, the y will become the exponent. Look at that. The answer is now the exponent. All right? How about the base? Well, it is called the base for a reason. The base the little number in the logarithm is now the base of the exponent, of the exponential function. All right? Okay. And the value we were applying the logarithm to, x, is now the answer. Don't worry, I know this bunch of lines and this bunch of changes look weird. So don't worry about this. I'm gonna do some examples about this. All right, don't worry about it. But the idea here is that you can change one into the other one. You can change one equation into the other one. All you need to know is just follow the order. Whenever it appears a y, you just put it as an exponent, right? The answer is now the exponent. Whenever the base is in the logarithm, now the base can be the base of the exponent. And the value of the logarithm is the one that is going to be the new answer of the exponent. All right? By the way, the domain of logarithm functions is this, x bigger than 0. Remember, domain, I think I'll explain it one of the last classes of the last term, right? One of the last classes of the last term. I explained what was the domain and what is also range, right? I think I explained it that, right? And I said domain changes depending on the function of the type of function, right? So this is the domain of logarithm functions. Logarithmic functions, sorry. X has to be bigger than 0. That's it. That is the domain. All right, let's jump into some examples. This is the good stuff. This is what we came for, right? All right, examples. Find an equivalent logarithmic expression. An equivalent logarithmic expression. So, in these three examples, what we are going to have to do is change this expression, which is an exponential. Look at this, has a base and has an exponent. A base and an exponent. A base and an exponent, right? These are exponential functions. So we need to change these exponentials into logarithmics. And for that, we're going to use our main transformation. Let me just have it here. I was the same, right? It was the same. I'm going to put it right over there in a corner. All right. I can't. All right, take a look at this. Let's try to change the first one, right? The first one. So take a look, guys. Since we are given the exponential expression, what we have is this form. This is what we have, right? This is the form we are given. And from this, we need to change into this one, right? So the first thing, the first thing we need to do is to recognize the values. What is x, what is a, and what is y, right? The function is written in this form. This is m equals 1.2 elevated to the 3. Now, notice how I changed it, the values, right? At the beginning, this was the exponent equals to the number, to m, right? And in this case, I change it. Why? Well, because that is the order that I have in my expression. That is the order. And I feel like that is better to be able to see what is what value, right? So from here, I know that, let me just erase that there. From here, I know that x, the value of x is our m, right? I also know that the value of a is going to be 1.2. Now this looks like a 9, sorry. A, there we go. And the value of y is going to be equal to the exponent, right? So 3. All right. Now that I have these three values, I can now change my expression. All I have to do is rewrite the new expression following the proper values. So this is going to be my answer. Here, I have y equals something, right? So the y is this one, right? Y equals 3. That is the y. All right. So I know I have a 3 over here because that is the value of y. Continuing with the expression, I have logarithm to the base a, right? To the base a. But I know the value a is 1.2. So this is logarithm to the base 1.2. All right, last but not least, the value of x, right? X is the one that comes, and for us, x equals m. So I'm just going to write it there. There we go. This is going to be our answer. Like this, we effectively changed one expression into the other. The exponential expression into the logarithmic expression. Remember, all we have to do is just follow the order of the values. That is it. That is it. Carlitos, you are correct, brother. You got it. Beautiful. That is the answer, brother. Yes. Let me show it how I did it here. Solution. 3 equals logarithm to the base 1.2 of m. Beautiful. Beautiful. All right, guys. Can you give it a try? Go ahead and try it in the chat. And a logarithmic expression for the second point. Give it a try, please. In case you want the expression, there it is. Let me just erase all of this. There. There. Like this, you can probably see what to change into what, right? This is the expression, and this is the expression, right? And we are doing this change from one to the other. All right, a lot of people trying it. Okay, I have one answer, another one, another one, another one, another one. All right, beautiful, guys. Remember, I am not going to read answers. So if you have a mistake, I'm not gonna tell you, because that will look like that would make it so people won't want to participate, right? I'm gonna write the answer, and like that, me writing the answer, you will know if you have it right or you had a mistake. But I want you to try, guys. Please, I want you to try. You're never gonna learn this stuff if all you do is just look at me, right? You need to try. Everybody, please, everybody. Not only the 1, 2, 3, 4, 5, 6, not only the 6 people who tried it already. No, everybody, please. Thank you, Maria Paz. All right. Thank you, Jesus. All right. All right. Okay. All right. Thank you, guys. Appreciate it. Thank you. Thank you. All right. The more you participate, the more you practice, the better you are going to get at this. Even if you are not sure, don't worry. Don't worry. I'll show you the answer, right? So don't worry about it. Okay, beautiful. Here we go then with the answer. Number 2. All right. Remember, the exponent is the one that is going to be the answer. Look at that. The exponent, let me erase this. The exponent is now the answer, right? So here the exponent was b. That means b is now the answer. We have b equal to something. Beautiful. What else? All right. We have a base, right? The base in this case is the letter e. All right. That base is going to be the base of the logarithm. So we know what comes next is logarithm to the base e. All right. And then by process of elimination, the last value is going to be the value of inside the logarithm. So logarithm to the base e of 9. Now, take a look at these guys. This is something that you need to remember. Whenever you find this piece of information, this logarithm to the base e, this one is the same as a natural logarithm. We call it like that. Logaritmo natural en español. En algunos libros lo llaman logaritmo neperiano.
Profe, ¿puedes repetir esa parte?
Yes, sir.
No.
Absolutely, yes. What I'm saying is that whenever you find this piece, this part, logarithm to the base e, right? It doesn't work with any other logarithm. No, just to the base e. If you find that, that is a special type of logarithm. It's called the natural logarithm. And you write it like this, ln. ln. That's it. That is how you write it. Ahora, en español se llama logaritmo natural o en algunos libros se llama logaritmo neperiano. Pero es exactamente lo mismo. Es el logaritmo con la base e. Recuerden que e es un numerito, ¿no? E es un numerito, pi es otro numerito, no sé cómo hacer phi. Ay, me quedó re mal esa phi.
Profe, y en inglés, ¿cómo se dice?
Natural logarithm. Logaritmo natural. Natural
Listo.
logarithm. No sé cómo se hace el phi. Ay, creo que ahí me quedó. Creo que ese es el phi, pero no sé. Es como. Ahí está. Phi. That's another value, right? All of these are numbers. This is a number, right? This is another number, right? This is another number. All of these are numbers, special numbers in mathematics, right? So whenever you have the logarithm base e, we know that this e is the special value. And that makes it so this is the natural logarithm of 9. Look at that. b equals the logarithm to the base e or natural logarithm of 9. What I'm trying to say here, guys, is that whenever we find the logarithm to the base e, we are no longer going to write that this way. We are going to write it in the compressed way. Natural logarithm. ln of 9. Here we had the logarithm to the base e of 9. So we have the natural logarithm of 9. ln. All right, let's continue with the last one. I see one of you already did the number 3. Can you give it a try, guys? Go ahead and give it a try, please. Find an equivalent logarithmic expression for the number 3. So change it. Change the number 3 into a logarithm. Remember, don't worry. I mean, if you fail, I'm going to show you the answer, so you will know where you failed. You will know where you failed. All right, beautiful, guys. All right, keep on coming, please. Come on, give it a try, guys. Give it a try. Analyze the exercise, change it into the possible answer, and that's it. All right, that's it. But participate, please. All right, we have a lot of answers now. Beautiful. All right, number 3. 4 equals logarithm to the base a of 24. The people who got it right, congratulations. Pretty good, guys, pretty good. Remember, the exponent is now the answer. The base of the exponent is now the base of the logarithm. And by a process of elimination, the answer has to be the value of the logarithm. That's it. That is it, guys. That is it. All right, we're going to do more examples of this later in the class. As of now, I want to do a little bit of an analysis here. Try to keep up with me, all right? This is absolutely simple, but try to keep up. Look, logarithmic functions, these logarithmic functions, look for the exponent. What? This is what I'm saying. Whenever you have a logarithm like this, logarithm to the base 2 of 8. What is the answer of that? If you take your calculator and write this down in the calculator, you will have an answer. Because remember, logarithms, since these are functions, these are operations, right? These will give you an answer. If you put it in the calculator, that is an operation. So you will have an answer. All right? Okay. How much is that? How much is that answer? How can we do this without the calculator? Well, take a look at this. Since we don't know how much that is, we don't know. We are trying to find how much logarithm to the base 2 of 8 is. Then we're going to call it x. Since we don't know, we call it x. All right? This is a variable. In mathematics, most of us mathematicians, whenever we don't know something, we call it x. All right? From here, we can change this logarithmic expression into an exponential expression. Remember, the result is now the exponent, right? The base of the logarithm is the base of the exponent. And by a process of elimination, the 8 has to be the answer of the exponent, right? From here, all I'm doing is the same process, but in this case, I'm changing from the logarithm to the exponential. And now from here, we can ask ourselves, to what number do we elevate it to get 8? In other words, what is the value of x here? 2 elevated to what? Gives me 8. 2 to the 1 will be 2. So x is not 1. 2 to the 2, all right? 2 to the 2 is 4. So x is not 2. 2 to the 3, 2 to the 3 is 2 times 2 times 2. That is 8. 2 elevated to the third power equals 8. So the exponent is 3. X has to be 3. That is what we were looking for, right? So remember, look at this, look at this. Look at this, look at this, look at this. Since x equals 3, I can just put it here. Because that is what we are looking for, right? This is the value that we are looking for. We are looking for the value of x. So there it is. Logarithm to the base 2 of 8, logarithm to the base 2 of 8 equals 3. Before, we didn't know how much was this logarithm. We didn't know that. We didn't know. But now, by changing this change, by making this change, sorry, and analyzing what is the exponent, now we know the answer. So that is exactly why I say that logarithmic functions look for the exponent. Look, in here, we had a logarithmic function, but the answer of that is one exponent. To what value do I elevate the 2 to get an 8? To 3. Thank you to Sarita, Ethan, and Majo. You guys are correct. You got it correct even before I said the answer. Beautiful, guys. Beautiful. All right. This is the power of logarithmic functions, guys. This is the power. Because now we can know what the hell is a logarithm. The logarithm looks for the exponent, which is why logarithms are the opposite, the inverse to exponents. We can now do logarithmic functions. Take a look at this. Take a look at this. What if I had this equation here? Now, of course, this is a really, really simple equation, this one. I mean, we all can know the value of x from here, right? We all can find it. What is the value that I elevate to 2 to get 8? Well, 3. So we know x equals 3. Right? But what if I do something harder? What if I do 3 to the x equals 7? How much is that? To what value do I elevate the 3 so that I get a 7? It's not that simple now, right? It is not that simple now. But you don't know. I'm sorry. But you know what? We can change this equation into a logarithmic equation. The exponent is the answer. And now we have logarithm to the base 3, because that was the base here, right, of 7. And if you put that in your calculator, guys, you will have an answer of, I don't know, a decimal value. I don't know, 1 point something. 1 point something. I don't know how much that is. Maybe one of you can tell me. I don't know. That is the answer, right? Before, we didn't know how much was x. We didn't know. But now, by making this change, now we can know. Now we can find the answer. Now we can know. This is the power of logarithmic functions. These. All right. This is the answer, right? All right. Before we continue with some beautiful and much needed exercises, let's talk about the basics facts. These are some basic facts. All right. If m and a, these are two values, right, are positive numbers, positive real numbers. We also know that a different than 1, because that is one of the definition of logarithms. Remember this value. The base cannot be 1, right? On r is any real number, then we have this. Look, logarithm base a of 1, logarithm to the base a of 1 equals 0. Why is this a basic fact? Why? Simple. If we were to change this into an exponential, we know that 0, no. The base is a, right? So the base a elevated to the exponent to 0 has to be equal to how much? A elevated to the 0. So any number elevated to the 0 has to be equal to 1. Give me just 1 second, please. Ay, tenía que estornudar, lo siento. Oh, I'm sorry. From here, right? This is the basic property of the exponentials. Any number elevated to the zero will give us 1. So we can change that into an exponential. And this will be the basic form of the exponential. Any number, right? The logarithm to the any base, the logarithm to the any base of 1 will always be 0. That is the same expression as I had before, but now I have it as a logarithm. All right. How about this one? The second one. Can you tell me why is this a basic fact? Why is this basic? Can any of you tell me? You can open the mic if you want to. Nobody? All right, cool. I'll explain it.
O sea, wait. It's like I have the idea, but I don't know how to say it. It's like because it's the same answer, so it has to be elevated to the 1 because anything times 1 time is the same.
Yes. Sarita, you are correct. All right. Yes. You know the answer, but you don't know how to say it. But you're saying it beautifully. You're saying it beautifully. All right. This is what you're saying, right? If we were to change this into an exponential, we have the base a elevated to the answer 1 will always be the same, a. Doesn't really matter. So we can have 5 elevated to the 1. That's 5. Or 3 elevated to the 1. That's 3. Right? So what we have here is the logarithm to the base 7 of 7 will always have to be 1. Because as Sarita said, any number elevated to the 1 will give you the same number. All right, that is the basic fact. How about this one? How about this fact? This one is hard. Can anybody say it? Can anybody say it? Nope. Wait. Okay, Carlitos, yo wait. I'll wait, brother. Don't worry, I'll wait. Give it a try. Don't worry. I'll wait. All right, my turn. I need to keep this class moving, brother. I need to keep this class moving. All right, this is why. We have 2 reasons why. We have 2 reasons why. All right. On one side, we know because I just said that exponentials in logarithms are opposite. So I can cancel this base of an exponent with this base of the logarithm, meaning that I have m equals m. This is one of the reasons. Another one is if I were to change this logarithmic expression into an exponential, what am I going to have? All right. So this is an exponential, right? This is base elevated to an exponent equals a value. This is an exponent. This right here, this is an exponent, right? So let's change this exponent into a logarithm. We have m. Let me change it this way. Logarithm to the base a, right? The answer is m, because this is what we have here. This is the answer, right? And the exponent is the answer of the logarithm. So look at that. Look at that. Look at that. What is the exponent? Logarithm to the base a of m. And that that is the same. Same thing to the left, then to the right. We are writing exactly the same. So this is a nice trick. This is a nice trick. What I have here is like saying as follows. 2 elevated to the logarithm base 2 of 8 equals 3. This is something that what I'm saying. This is something what I'm saying. Oh, no. Equals 8. Sorry, I made a mistake. Equals 8. Right? This is the same. Why? This is the same. Why? Look at this. This value. How much is logarithm to the base 2 of 8? We know that this value is 3. We already did that operation. Right? So this is 2 elevated to the 3. Well, that is 8. It's exactly the same. Right? Richie, profe, ¿lo puedes repetir? Lo puedo repetir, man. Lo voy a volver a hacer en españolito en esta vez. ¿Listo? A ver, voy a copiar aquí el proceso de pasar de una expresión a la otra. Ponle cuidado. Vamos a ponerlo acá, a ver. Sabemos que esto es un exponente, ¿no? Esto es a elevado a la x igual m. Estoy llamando todo este logaritmo, estoy llamándolo x, ¿listo? Eso es un exponente, ¿cierto? Entonces queremos pasarlo al logaritmo. ¿Se acuerdan cómo se pasa? El logaritmo sería entonces, logaritmo. La base sería la base del exponente, ¿no? O sea, logaritmo base a, ¿cierto? M, que es la respuesta del exponente, se va a volver ahora el valor al cual le aplico el logaritmo. ¿Cierto que sí? Y el exponente va a ser nuestra respuesta. ¿Cierto que sí? Así pasamos de una expresión exponencial a el logaritmo. ¿Cierto que sí? Ok. Entonces ahora escribamos esta exponencial. Bueno, pues el exponente era logaritmo base a de m. Eso era x, ¿cierto? Yo lo escribí x para que fuese más rápido. En vez de escribir todo ese larguero tan horrible, lo escribí como x. Pero ahora escribámoslo larguito. Mira, esta x es entonces el logaritmo base a de m. Esa es la x. Y al otro lado de mi logarítmica tengo logaritmo base a de m. Entonces, tanto a derecha como a izquierda de la igualdad, tengo exactamente lo mismo. Sin importar cuál sea el valor de a, aquí va a ser la misma base. Sin importar cuál sea el valor de m, aquí va a ser la misma base. Luego, entonces, esta escritura que está aquí a la izquierda, esta, es cierta para todo valor de a y de m. ¿Mejor, Richie? ¿Richie? Profe, ¿cuál la? Del principio, ¿cuál la? Mira, ¿esta de acá o cuál? Esta de acá, no sé cuál la. Sí, esa, pues mira, aquí está, mira, esta A, que es la base del exponente, es esta, ¿cierto? Y como lo estoy pasando a logarítmica, pues la base del logaritmo se vuelve la base, perdón, la base del exponente se vuelve la base del logaritmo, que es esta misma que está acá. ¿Sí? ¿La viste mejor? Ok, dices que ok, listo. Ok. Con gusto, papá. Ah, este estaba fácil. No estaba facilito, pero estaba bien chévere. All right. Another one. How about this one? How about this basic fact? Now, this one looks hard, but it is not. It's not. Can anybody try to explain me, please, why this is a simple fact? Why whenever we have the logarithm of the base 1 of, I'm sorry, the base logarithm to the base a of a to the r equals r. Why is this like that?
The bases cancel.
Yes, sir. Ethan. Yes, sir. Just like the previous one, Ethan. We have a logarithm and we have an exponent. So we can cancel the bases. Logarithm of a and the base of the exponent, leaving us just with r. Well, the answer has to be r. Yes, sir. Ethan. Beautiful, brother. There is also another explanation. Again, we can change these into... what happened? There. We can change this into an exponential, right? This is a logarithm. So we can change this logarithm into an exponential, right? Remember, base of the logarithm will be now the base of the exponent. The value is now going to be the answer. And the answer is going to be the exponent. And look at that! Everything to the left is the same as everything to the right. So the exact same the exact same analysis as the previous one. Look at that. Look at that. All right. These are some basic facts, all right? Now, these are the easiest facts. These are not properties. Properties are something different that we are going to discuss later. We're not going to do it today because I want you to practice these basic facts and also how to change this, how to change equivalent between logarithm expressions and exponential expressions. And to do that, guys, let's get to work, please. We have this amount of exercises. Let's get to work. From 9 to 36, just the odd ones. Remember, odd means impar. How did you know that? A propósito, how did you know that? How did you know if odd is impar or par? How do you know that? I have a trick. I think I explained it to some of you already. Does anybody know the trick?
Because it have
Because you have 3 letters.
Yes,
And three
guys,
is not-
beautiful. Yes, sir. That is the trick, right? So odd has 3 letters, right? 1, 2, 3. So this is impar. How about even? Well, even has 1, 2, 3,
4
4
letters.
letters. Par. Odd, 3 letters, even 4 letters. 3 es impar, 4 es par. All right. That is the trick, guys.
Solo aplica en inglés, porque en español es como par, es como 3 letras. Entonces,
Uh-huh.
raro.
Yes, sir. It only works on English. Yes. I don't know in French. Or I don't know in any other language, right? I don't know. But in English, it works, right? All right. These are the exercises, guys. Do only the odd ones. If you finish the exercise and want to practice a little bit more, then jump into the even ones. But I don't know. I don't think you're going to have enough time to finish this, right? If you don't worry. We'll continue in the next class, right? Get to work, guys.